Right, so today we're going to start talking about representing proportional relationships. And the problem we're going to look at is this one. Jada and Noah counted the number of steps they took to walk a set distance. To walk the same distance, Jada took 8 steps, while Noah took 10 steps. So that's my first important information. Jada took 8, while Noah took 10 steps. Then they found that when Noah took 15 steps, Jada took 12 steps. And in your first task here under A, they ask you to create a table to represent this situation. So that's what I'm going to start with. I'm going to draw a little table here. To represent the situation. So in my first row here, I'm going to put Jada. And in my second row, I am going to put Noah. And I'm going to put that first set of information that I have. It says here, Jada took 8 steps, while Noah took 10 steps. So I'm asking you, if Jada took 8 steps and Noah took 10 steps, how many steps would Noah take if Jada took 4 steps? And this is a proportional relationship. So here, from 8 to 4, I'm dividing by 2. Actually, this should be done intuitively, but if Jada takes half the steps, Noah also needs to take half the steps, which is 5. So I've already put down 2 pairs of values. They ask you to do 3. I'm going to show you a few more than 3, just so that you get the hang of it. What about if I am asking you, okay, we were talking about 8 steps, we're talking about 4 steps. What if I say, okay, if Jada now takes double the steps, so instead of 8, she's going to take 16 steps. How many steps is Noah going to take? Noah is obviously also going to take double the steps, which would be 20. And you can go on like this. You can triple, you can quarter. It doesn't matter what you're doing. What is important is that whatever you do to Jada's steps, you also need to do to Noah's steps. So if you triple Jada's steps, Noah is going to take triple the amount of steps in the same time, and so on and so forth. And I'm also going to put that second set of information, the 15 steps and the 12 steps. So when Noah took 15 steps, careful here, Noah took 15 steps, Jada took 12 steps. Okay? So that's it. And also you could have worked with these 2 values. So you could have said, okay, if Noah takes only 5 steps, so a third of the steps that he took initially, how many steps is Jada going to take in the same time? So if he takes 5, then that's a third of his initial steps. Then Jada also can only take a third of her steps, her initial steps. So that would be 4. And when you have a closer look, you can see that we had that value here already. We got that by halving Jada's initial steps. Okay, so this value comes up twice here. Now, in our second task, under B, it asks us to graph this situation. So to graph this situation, we're first going to start by drawing our axes. So I have my 2 axes here. Remember, please always label your axis. This is my y-axis. This is my x-axis. And my x-axis is going to represent Jada's steps. My y-axis is going to represent Noah's steps. And then I'm going to plot these steps. So I'm going to make here, so I'm going to go up in twos. So that would be 2, 4, 6, 8, 10, 12, 14, 16. I'm going to do the same here. I've got here 2, 4, 6, 8, 10, 12, 14. And then I'm going to start plotting my first pair of values here. So Jada is taking 8 steps, so that would be 1, 2, 4, 6, 8 steps. And then Noah at the same time is taking 10 steps. So that would be 2, 4, 6, 8, 10. So that's where I'm ending up. So this is the point that I would like to draw on my axis here. This one here. And you can see that on the graph that I have been drawing, I won't be able to put this one because Noah is taking 20 steps. My y-axis only goes up to 14. So when you're graphing, it does make sense to look at your smallest and your biggest value and try to make it fit, okay? I have another set of points that I can draw though. This is this one, for example. I could draw this set, which is 4 and 5. So when Jada takes 4 steps, 2, 4 steps, then Noah takes 5. So that would be 2, 4, and the 5 would be right here in the middle. So I'm going to draw that point there. And I could also still draw this pair of values, Jada taking 12 steps, Noah taking 15 steps. So I'm going to go for Jada 2, 4, 6, 8, 10, 12, and Noah 15. So I'm going up 15, 2, 4, 6, 8, 10, 12, 14. 15 is going to be right here in the middle. So I'm going to plot this point here, right there. And what I need to do next is I need to connect those points with a straight line. I'm going to do that now. And that's what it looks like. And this is the graph of a proportional relationship. And there's a few things that I want you to note here. The first thing is that a graph of a proportional relationship always goes through the origin. It always starts down here. Another thing that I want you to note is that you can read off the gradient. The gradient of this would be 8 to the right, 10 up. So you can draw your triangle here. You can draw it elsewhere, but you could also draw it here. And you can read off your rise over run here. And my rise would be 10, my run would be 8. So I'm going to write this down. My gradient of this line, gradient is equal to rise over run. And here it was 10 over 8. And you can simplify that to 5 over 4. And you can find this value also in your table. Here. Or here. So y over x gives you your gradient. Thanks for watching.